Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Air data instrument. In this module, we are going to study about the airspeed indicator, the altimeter, and the vertical speed indicator. For each of these, we are going to study about the introduction, the types, working, error, and the uses. Take a look at these topics. Here is a pictorial representation of the air data instrument. The pitot pressure. The pitot pressure is obtained from the pitot tube. The pitot pressure is a measure of the ram air pressure, that is the air pressure created by the vehicle motion or the air ramming into the tube, which under ideal conditions is equal to the stagnation pressure, also called as the total pressure. The pitot tube is most often located on the wing or the front section of the aircraft facing forward, where its opening is exposed to the relative wind. By situating the pitot tube in such a location, the ram air pressure is more accurately measured, since it will be less distorted by the aircraft structure. When airspeed increases, the ram air pressure is increased, which can be translated by the airspeed indicator. The static pressure. The static pressure is obtained through a static port. The static port is most often flush-mounted hole on the fuselage of an aircraft and is located where it can access the airflow in a relatively undisturbed area. Some aircraft may have a single static port, while others may have more than one. In situations where an aircraft has more than one static port, there is usually one located on each side of the fuselage. With this positioning, an average pressure can be taken, which allows for the more accurate readings in a specific flight situations. An alternative static port may be located inside the cabin of the aircraft as a backup for which when the external static ports are blocked. A pitot static tube effectively integrates the static ports into the pitot probe. It incorporates a second coaxial tube or tubes with pressure sampling holes on the sides of the probe outside the direct airflow to measure the static pressure. When an aircraft climbs, static pressure will decrease. Here is a pictorial representation of the pitot static instrument. Introduction to the airspeed indicator. An instrument that measures the speed of an aircraft relative to the surrounding air using the differential between the pressure of still air, that is the static pressure, and that of moving air compressed by the craft's forward motion, that is ram pressure. As the speed increases, the difference between these pressure increases as well. VSO indicates the stall speed in landing configuration. VS, stall climb speed in the clean configuration. Vy, climb speed for the max amount of height for the distance. VFE, flap extension speed. Flap should not be used above this speed. VA, design maneuvering rough airspeed. The speed at which abrupt full control input can be used without risking structural damage should never be exceeded in rough air. Changes with weight. VNO, maximum structural cruise speed. White arc, flap operating range. Green arc, normal operating range. Yellow arc, caution area. Red arc, never exceed the speed. Here is a pictorial representation of the airspeed indicator, which shows all the parameters. Let us look after some terms. The indicated airspeed. It's read write of your airspeed indicator and is usually what you'll reference in the cockpit for speed changes. The speed limits of the sky, like not exceeding 250 knots below 1000 feet MSL, are all written as indicated airspeed values. The true airspeed. True airspeed is the speed of your aircraft relative to the air it's flying through. As you climb, true airspeed is higher than your indicated airspeed. Pressure decreases with higher altitude, so for any given true speed as you climb, fewer and fewer air molecules will enter the pitot tube. Because of that, indicated airspeed will be less than the true airspeed. Calibrated airspeed. Calibrated airspeed is indicated airspeed corrected for the instrument and positional errors. At certain airspeed with the certain flap settings and installation and instrument errors may total several knots. This error is generally greatest at lower airspeed with nose high pitch altitudes. Working of airspeed indicators. Static pressure enters the ASI case while total pressure flexes the diaphragm which is connected to the ASI pointer via a mechanical linkage. The pressures are equal when the aircraft is stationary on the ground and hence show a reading of 0. When the aircraft is moving forward, air entering the pitot tube is at a greater pressure than that of the static line which flexes the diaphragm moving the pointer. The ASI is checked before takeoff for a 0 reading and during takeoff that is increasing appropriately. This picture shows the working of the airspeed indicator. Error of the airspeed indicator. If the pitot opening is blocked but the drain hole is open, the system pressure will drop to ambient pressure and the ASI point will drop to a 0 reading. If both the opening and drain holes are blocked, the ASI will not indicate any change in airspeed. However, the ASI pointer will show altitude changes as the associated static pressure changes. If both the pitot tube and the static system are blocked, the ASI pointer will read 0. If the static ports are blocked but the pitot tube remains open, the ASI will operate but inaccurately. This diagram indicates the error of the airspeed indicator. The uses of airspeed indicator. An instrument that measures the speed of an aircraft relative to the surrounding air using the differential between the pressure of a still air, that is static pressure, and that of a moving air comprised by aircraft's forward motion, that is the ram pressure, and the speed increases, the difference between these pressure increases as well. The altimeter. Altimeter is an instrument that measures the altitude of the land surface or any other object as in the airplane. The two main types of the pressure altimeter or aneroid barometer which approximate altitude between sea level by measuring atmospheric pressure and the radio altimeter which measures absolute altitude distance above land or water based on the time required for radio wave signal to travel from an airplane, a weather balloon or a spacecraft to the ground and back. This is a pictorial representation of the altimeter. Let us get to know about the working of altimeter. The pressure altimeter operates on the principle that the average atmospheric pressure decreases linearly with the altitude. The instrument is enclosed in a case that is connected to the outside of the aircraft by an air pressure inlet at the rear of the housing. Two or more aneroid capsules, that is thin corrugated metallic bellows from which air has been exhausted, are positioned near the inlet. These capsules expand when the outside air pressure falls as in climbing and contract when the outside air pressure rises as in descending. By a mechanical arrangement of sector gears, pinion, backlash spring and crankshaft, the expansion of contraction of the aneroid capsule is converted to the movement of pointers on a dial. The graduated scale dial is marked off in meters or feet, and a series of gear-driven pointers similar to the hands of a clock may be used to indicate the altitude in units of hundreds, thousands or tens of thousands. The barometric scale dial records the air pressure in the millibars, that is MB. Because atmospheric pressure is measured relative to sea level, a pressure altimeter must be adjusted with a bar setting knob in order to compensate for small variations in barometric pressure caused by changes in local weather. Let us have a look at the types of altimeter. The radio altimeter measures the distance of an aircraft above the ground rather than above the sea level. The altitude is equal to one half of the time that it takes a pulse of radio energy to travel from the aircraft to the ground and back, multiplied by the speed of the pulse, which is equivalent to the speed of light. The measured altitude is displayed on a video screen. Radio altimeters are used in automatic navigation and blind landing systems. This figure right here shows the types of altimeter. The errors. There are several factors that can impact the accuracy of an aircraft's altimeter, which will induce altimeter errors. Non-standard temperatures of the atmosphere, non-standard atmospheric pressure, aircraft static pressure system, which is position error, and then instrument error. The uses of altimeter. Altimeter measures the height of an aircraft above a fixed level. The instrument senses this by taking ambient air pressure from the static port. Now let us talk about the vertical speed indicator. A vertical speed indicator VSI, which is also known as rate of climb and descent indicator RCDI, is an instrument that indicates the rate of climb or descent of an aircraft. The VSI uses the aircraft pitot static system to determine the vertical speed and depicts the result on a conventional needle and circular scale instrument or on a ribbon at the side of an electronic flight instrument system, which is called as EADI. Have a look at the vertical speed indicator picture. So how does the VSI work? In a VSI, a barometric capsule is contained in a sealed case. The capsule is fed with the static pressure from the pitot static system, while the case is also connected to that system through a calibrated nozzle. The nozzle restricts the passage of the air so that there is a time delay between change in static pressure and the pressure being experienced with the case. Thus, if the aircraft climbs or descends, the pressure within the capsule will rise or increase, while within the case it will increase at a lower rate due to the presence of the nozzle. The movement of the capsule is translated into a movement of a needle by a mechanical system. Have a look at this picture of working of VSI. Errors. An error in a VSI vertical speed indicator in which the static source is blocked. Since there is no differential pressure in the system when the aircraft climbs or descends, the VSI will continue to show a level flight even when the aircraft is climbing or descending. In the case of partial blockage, the VSI will be under red and there will be a more than usual lag when the aircraft levels out. The uses of VSI. A vertical speed indicator, also known as the rate of climb, and the descent indicator RCDI, is an instrument that indicates the rate of climb or the descent of an aircraft. This was all about the air data instrument. Thank you.